And we're live. Hello, ladies and gentlemen. Welcome back to another episode of The Good Thing. I'm here with my co host, Jens, and today we have an interesting episode. We're going to be kind of just talking about beyond GraphQL, some observations that we got from some of our friends at KubeCon, AI, of course, and just more about GraphQL, Federation, and just scalable API architecture. Jens, always a good to talk with you. Welcome back. How are you?
Hi, Stefan.
I come in with the energy, and you're just like, "Hi, Stefan."
Yeah, yeah. I'm a little bit under the weather, but it's fine. At least I can speak again. And but today is barbecue weather here in Germany.
Okay.
So this podcast is currently is in between me and the barbecue.
Okay, and thank you, ladies and gentlemen. That's our episode today. I'm just kidding.
No,
You-
it's fine. Like I would say in an hour and a half it's barbecue o'clock, so that's fine.
no, I love that. I'm a big barbecue guy. I think you know that. Like growing up, my dad barbecued every day. Not like every day, but like every other day. And then sometimes I would come home and he's just barbecuing a whole pig. And I was like, why are you roasting a whole pig? He's like, it's Saturday. I was like, okay, like can't complain. But no, that's awesome. But thanks for joining us as usual. I mean, you're my co-host. But one thing I want to talk to
I
you
had
about the
no choice,
audience.
right?
Yeah, no, you
Hey
have to
Jens, we
join it.
do we need to do the podcast. Can you come?
But one thing going forward is that we are going to start introducing guests onto the show. And so our amazing content producer, Jacob, he's going to be sourcing guests. If you guys are interested in coming on the podcast and chatting about things with software engineering, APIs, GraphQL, or just startups in general, feel free to reach out to him at jacob@wondergraph.com. But for the next couple of episodes, we're going to be having some amazing guests from some companies that you guys know and use every single day. But today, you're stuck with me and Jens. Jens, let's start off with what we were talking about this morning. So one of our friends, and you feel free to mention him, but he went to KubeCon and he gave us some interesting observations of what he saw at KubeCon and just kind of what happens each year at KubeCon. But I don't want to take your thunder. Maybe explain what did he see at KubeCon? What is KubeCon? And what trends do you see the tech world going into?
So he said KubeCon was 13,000 people, so probably a quite crowded place.
Jeez.
And he also said that KubeCon it comes in waves, or the topics they come in waves. And yeah, this year it's AI, obviously. And the big question you have to ask yourself is, if you are, for example, in the API space, do you actually want to be there? It's not cheap. And if everybody talks about AI and you don't really have an AI topic, or yeah, I'm not sure if maybe if you implement some MCP thing, then okay, maybe that's enough AI, but probably people will be more interested in talking to the real AI players. So yeah, I'm not sure that there might be better ways for a company like ours to promote API tooling. So that's just I would say the observation.
And with KubeCon, I mean, 13,000 people, that's that's a lot of people. And then with AI, like, this is what I'm trying to understand. So like I was born before the dot-com burst by like 3 years. I was just a baby. And what I've noticed is history tends to repeat itself. And so you had the dot-com boom, and then you had the shift towards cloud, and then you had the shift towards mobile. And then now we're in this wave of AI that everyone is hopping on it. That you can see every company is rebranding to AI. Where does AI come into with APIs? Like APIs might not be sexy as AI, but you can't have AI without APIs. Would you agree to that?
I mean, um, Anthropic and ChatGPT or OpenAI, um, I think they make it very clear with MCP, the Model Context Protocol, that AI needs APIs. And actually, I think MCP it kind of stands for AI is useless if it cannot call APIs. And
Yeah,
and
kind
and
of.
like, if you put ChatGPT in a box and you don't allow it to access to the internet and you don't allow it access to your file system, Cursor is AI with access to your file system. So if you remove that
It's
and
useless.
don't allow AI to talk to your systems and to the internet, so no systems, then I don't know. It's just a really cool thing in a box, and it's a toy. I think with MCP, all of this rapidly changes, and we can do so many new cool things. And yeah, I think there's a big drive in the direction of agents, and like one very clear thing that we observe so far is you cannot trust AI. It does
Yeah.
some things. It also doesn't think. It predicts tokens, and it predicts tokens in a amazing way. Like in
That's a
many
good job.
cases, it can really predict good tokens. But for example, like we're now using AI at WonderGraph for quite some time with Cursor and other tools, and our observation is that you define tests, and you like if a human works test driven, they define tests and they implement the tests, and they actually have an incentive that the tests work because they know like someone will review them, and
Yeah.
they like a human doesn't like developers are lazy. So if you write tests and then you implement code that makes the test go green but it's wrong, someone will review it and tell you like, hey, you need to do this again. It's garbage. So humans are incentivized to write code that works. Combine that with tests, and you can get good code.
Sure.
AI doesn't care if you call it twice or a billion times. It's just a program. So there's no incentive to write correct code at the first run. And also AI doesn't know what is correct. And it also doesn't care. It predicts tokens. So you write a test and then it runs the test and it sees, oh, it's failing. Let's do things so that the test maybe doesn't fail. And it can sometimes predict the right thing to do that. And sometimes what I saw is AI reads the content of your test and then it, for example, puts code into your implementation that references things in the test, and then it works. Like for
Yeah.
example, you need to parse a GraphQL query, and instead of parsing it, you just write code where it's like, if the string is blah 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 blah, then do the following thing, and now the test works because it looks like you had written a parser, but actually you're just matching strings. And
Yeah.
yeah, of course, the test is green, but yeah. So I don't know. It would be cool if AI was incentivized to do the right thing. But again, what is the right thing? So yeah. So up until today, our jobs are safe.
I didn't
We
say
don't know
yeah.
about tomorrow, but I don't know. Maybe we need some sort of counter. Like, is our job safe today? Yes, but tomorrow we don't know.
It's a good point, but the thing that kind of I'm confused about, and I think it's what's so important about disruptive technology is that when technology is truly disruptive, all rules and all principles that you had before that, they go completely out the window. And what I mean by that is, for example, with Mac, you have to really give it access to your file system. Like any program that you install on Mac, you have to
With
go through
what?
a couple
Mac.
with MacBook. Yeah. If you go with MacBook and you want to like install a program that has access to your file system, you have to do a couple steps to do that. And you have to make sure that you give it access. And what's crazy to me is that with like the introduction of ChatGPT and all these AIs is all the rules went out the window. Publicly traded companies are giving access to Cursor, to proprietary code, to proprietary software that they've built in-house. And like what are your thoughts on the ethics of AI? Like, for example, like how are people just giving AI access to their file system? Billion-dollar companies that have built up from the ground up on this proprietary software are giving it to a brand new startup that just is just around. Like, how can we just give AI access to our code, to our billion-dollar ideas, to everything? Isn't that kind of scary to you or not?
Mm. It might not be your desired answer, but actually, I think there's not so much value in most code. There's value in we have a bunch of people who understand this code good enough,
That's
and we
actually a good
can
point.
change it, and we have distribution and stuff. Like, imagine I gave you the code of Meta, so you don't have the data but the code. So can you now build a social network?
I don't have no,
I
I
mean,
can't.
you would have to change people's behavior to move on from Meta to Meta 1
That's
or
fair, yeah.
whatever you call it. So yeah, we can give you the code, but maybe there's something in the code that is more malicious. For example, there can be code like an algorithm about the feed, or I don't know, if people had the code, they could somehow cheat to show more ads or to prioritize ads or whatever. So there can be harmful ways, but I don't know. I think most code could actually be open source,
Should
because
be.
like the moment you open source it, it's kind of outdated, because we all have roadmaps. Like, we don't live in the past. Like, if you look at Cosmo today, um, who cares about Cosmo today, because we have a vision for Cosmo tomorrow. So what is our mode? Our mode is the ability to create this tomorrow, and we have customers, and we have a go-to market, and we like all of this together. It's kind of like, I don't know, our mode, I would say. But just the code, and that's also why I think it's so harmless to, and even
Yeah.
beneficial to make Cosmo open source, because like more people can collaborate. But I would say in the ecosystem of tomorrow, like Cosmo, it will not stay our single product. So we're building a universe of products, and uh, not all of them will be open source, but most. And yeah, I mean, yeah, do with Cosmo whatever you want. Yeah, okay.
It's well
I,
said.
I I completely went off the rails.
No, no. I mean, it's typical. No, it's well said. I mean, there isn't really that much value in the code. Like, it's everything that you build around the code, the distribution, the brand, the network. And it's exactly the same example as that. Okay, like people always say I could vibe code a Salesforce in a weekend. Like, yeah, you can, but there's no way you can touch the distribution. There's no way you can touch the brand of Salesforce. And so it's not even about the product anymore. It's about everything around the product. But no, it's a good point. But with AI, like, and what we saw at KubeCon and what our friends told us at KubeCon is with Federation and AI, and there is no AI without APIs. Where does AI fit into Federation? Where do you see it going? Where do you see the benefits of AI into Federation, especially for people that are considering adopting the super graph, people that are considering going into a micro services architecture? Where do you see the benefit of AI there? And you can go off the rails for this one. It's okay.
Yeah, I'm sometimes I feel like a politician. I have a message I want to send. You ask a question. I start with, yeah, thanks for your question, and then I send my message.
Well, what's the message you want to send?
No, okay, AI and Federation. So obviously, I say this so often. I'm not sure.
You're
It
biased,
can
bro.
even be insulting, because it's not always obvious, like, to everybody. Okay, but if you have a super graph, it means we have all your APIs combined under one protocol. Now with AI, it can be a challenge for AI to talk to many APIs with many protocols. And if you, let's say you give AI a task and it needs to talk to 10 APIs. And so I think that alone is a question, is a challenge. And now imagine AI has to speak 10 different protocols like SOAP, REST, OpenAPI, Postgres, whatever. I think then AI will struggle even more. And I think it can be much easier for AI to do the task if we had one uniform interface. And then if we take this a step further, we can say, okay, let's take MCP into consideration. So model context protocol. So for the people who, I don't know, I don't even have a good explanation, but for me, MCP is I create a bunch of operations. I create JSON schema for them so that AI knows the input and output. And I add some documentation so that AI can read the description and knows, okay, I can call this function and it does some stuff. Okay, so that's great. So now AI can use MCP and talk to all my things. Now you have a next challenge, because it means we will actually create an ecosystem to unify everything to speak MCP. And if you build a microservice architecture, we are back in API gateway territory, because do you really want, let's say you are big, like very big company, and you have hundreds of microservices because you have so many teams. And these microservices are actually good, so it's fine. We're not debating microservices here. So you have all these services, and now AI through MCP should talk to all these services. Do you want every team to build an MCP server? Which means everybody needs to protect against AI not doing mutations, not going rogue, whatever. You might want to have observability. What about permissions, authorization? So again, like MCP, from my point of view, it's just an API user. And for a very long time, I think many people in this economy, in this API economy, they agree. If you have that scenario, you should have an API gateway. And now you can shoehorn this topic and be like, okay, we now create an AI gateway for MCP. But in reality, it's just an API gateway, and MCP or LLM, it is just an API consumer. Okay. And so coming back to your question, Supergraph or Federation and MCP or AI, how does it fit together? If we build a supergraph, we have a single approach. We have a framework of how to bring all our services together. And second, if we have this, we can now create an MCP interface on top, which is what we're currently doing. So we're currently working on this topic, where you say, okay, MCP, what is MCP really? You have a function or multiple functions. They have a description. They have an input and an output, and input and output is described as JSON schema. So actually, for me, MCP is a collection of GraphQL queries, because a GraphQL query can have a description. GraphQL gives you back JSON. The input can be JSON, and I can transform the AST of a GraphQL query in a way that I get a JSON schema for the input, I get a JSON schema for the output. So if I have Federation and the supergraph and I have AI, I create a collection of GraphQL queries, and now I can, with this collection, I can give MCP fine-grained access to my supergraph. And this MCP, it will go through a proxy. This proxy, it can live in the Cosmo router. And this proxy can ensure that, let's say, a client is allowed to do mutations or not. We can control what kind of operations it makes. Cosmo Router already has observability, so we know what an agent is doing. And so, yeah, now we have a very good approach to create MCPs. And where I think where the real benefit is, of course, you can do it without federation, without the graph and everything. But the real benefit is all backend devs, we just tell them build subgraphs. And then if you want to create an MCP interface, you just create a collection of queries. And this collection, you somehow persist it, store it. And now you have an MCP instance. And so we can almost build a no-code, low-code way of, just open the browser, create a collection of queries, and now you have an MCP interface. And it's protected. We have analytics for it. We can see exactly what kind of calls is AI making. Maybe AI is doing the wrong calls. I think there's a great match. Can you do it differently? Yeah, of course. But I think what we kind of need to figure out is, so our approach, obviously, we have huge investments in Federation, so we will continue that. And our approach, and like what I just said, like take it with a grain of salt, of course, because Federation. But even if you're not using our approach, you somehow need to figure out, okay, I need to take REST, SOAP, Postgres, whatever, external services. I somehow need to unify it to put an umbrella on top, JSON RPC for MCP. I need to add protection, rate limiting, security, authorization, and observability. So you have to do it anyways. Yeah. And now is the question, so many of these parts, like API gateways can do it, like Kong. But what API gateways don't do is they don't unify all the stuff into MCP. And I think creating an MCP by writing GraphQL queries, that's pretty easy. And you can even, we're experimenting with this, you can even use AI to turn a prompt into a query. So it's pretty easy to do. If you don't do it this way, I think you need to, and we will probably see this. We will now see, there was a wave like startups who create SDKs. And I think now we will see a wave of startups who help you create MCP servers for all your internal stuff. And they will reinvent parts of Federation.
It's well said. And it makes sense when you put it that way. It's funny that you said that, like the waves of making SDKs, because we did that. So we were in that wave. We pivoted, we left, which was funny. But one thing about AI is every company is shifting to an AI company. And I was actually talking about this with Dax the other day, is so many companies with AI, like the ones that are providing the services, that are providing the graphics cards, like NVIDIA, and that are providing the actual services to help AI companies, man, they're going to make an absolute killing. But side note, so that's the future of Federation. Let's go back a little bit in time and just talk a little bit about like how Federation came across, because Federation is kind of a new concept. Would you agree? Like officially Apollo Federation was released in 2019, but Federation as a concept is not that recent, right? It's kind of a new approach to a microservices architecture. And I want to get your opinion on this, and then we'll go back to where we were right now. But in 2018, I forgot what company you were at, but you ended up going to a conference, and we talked a little bit about this, but that's where you were introduced to GraphQL and the data. What was it? The DGS data graph layer? Or what was it?
I at Tyke, I created the universal data graph.
The universal data graph. And this has been talking about for like 6-7 years, and nobody's actually really done a great job on it, like creating this universal data graph. But talk to me a little bit about the history of Federation. Like, has Federation been done before? Why aren't more companies on Federation? Like with the companies that we see, they make sense and they love it and it does great. But why isn't every single company on Federation is what I'm trying to get to.
I think.
And don't answer like a
Apollo did.
politician. Don't answer like a politician.
What? No, I'm not.
Okay,
I
good.
think Apollo did a lot of things right, and also some mistakes were made along the way. No, I think the coolest thing Apollo created is this idea of entities and the key concept. Like you have an entity, and it can be addressed with a key or with a composite key, and you can jump between subgraphs and then get more data for an entity. That's the best. It's a great concept. I also think starting Federation in the GraphQL space was a good idea. I mean, it was a natural fit from where Apollo was coming from. I think that's really strong. You have a great client ecosystem. Like GraphQL is generally speaking, it's front end driven. Like
Yeah.
most people, it's not like anybody in the backend is like, hey, I really want to do Federation. It's more, or I really want to build a GraphQL server. It's more like front end guys say like, hey, we want to use Relay. Can somebody make it work? And then okay, people figure out, okay, Relay, we need a GraphQL server, and then they realize, okay, we actually want to build the GraphQL server across multiple teams, and some teams own some parts of it. Okay, we do Federation. But I don't know. I think in the meantime, honestly, I think in the beginning, Apollo had too much success, and it kind of killed them because they absolutely stopped innovating. I think the biggest mistake they made is just, I don't know, not thinking further, because Federation is such a powerful concept. Staying within the GraphQL realm is such a big mistake. And what they are now doing with connectors, I talked to a lot of experts about connectors, and so I wanted to know what is the take of people, like how do they think about connectors, what do they see in them. And I asked them in a very unbiased way. I also will I will do a write-up on this in a while, but currently I'm doing a write-up on another topic. But the topic of connectors, or the direction they are taking, so their approach is now, how can we help you to get REST APIs as quickly as possible and glue them to the graph?
Yeah.
And there's also this ongoing process of this working group to rethink Federation to be more GraphQL native.
Yeah.
I think both endeavors are, like, I think it's good to eventually have a specification for how GraphQL Federation should work.
Yeah.
And at the same time, I think Federation as a concept is limited by GraphQL. It is a good idea that, oh, he finally said it.
Yeah. I mean the episode is called Beyond GraphQL, and just say it one more time, just so Jacob can clip it. That yes. So Federation is limited by GraphQL. So what do you mean by that?
Okay, so we have a router, and it speaks GraphQL, and I think it's great that it speaks GraphQL, and it will always speak GraphQL. It's like, for people who use Relay, it's amazing. Like, GraphQL is amazing for people who use Relay. For everybody else, it's just a burden, because what most people actually want is an SDK and not building queries. Like, nobody wants to build queries, but if you have Relay, it's a completely different world, because with relay you define fragments of what data do I need for which component, and like clients like relay, for example, there's also isograph from a friend, Robert Balicki, at what company is he currently working at?
So Robert was at Meta, but now he's at Pinterest.
Yeah, okay. And so yeah, clients like relay or isograph, they are so powerful in that you get yeah, the way you can build client architecture. I think if you reach a certain scale of an application, it just becomes unmaintainable if you have something like TRPC or REST APIs. You're making like too many calls and everything. And this is really where those clients shine. I think there was also a while ago, there was a big post by what is the website again? It has something to do with crypto.
Was it Coinbase?
Yeah, I think Coinbase. I think they are also using Relay.
They are.
And yeah, if you build a large front end app like something like Relay, it's just fantastic to work with. So much type safety. You can easily refetch data and everything. By the way, one thing, I'm going on a tangent on my tangent, but we are intending to bring native support for Relay to Cosmo Router, because I personally like there's no value in doing it. Well, there's maybe value, but like we're not making money from doing it because it's just open source. But sometimes I want to do things because I think they are right, and I'm running a company, but also I don't know, I have a feeling for how should things work. And I think one thing that Federation, or at least our implementation of Federation, should have like native support is Relay. So what we're in Relay, you have this node interface. Do you know what the node interface is?
Me, I don't. So feel free to explain it for the audience because they might not as well.
So if you have a front end, and in your front end there's, let's say you have like a like a feed, and you have a feed item, and now you have a list of feed item things, and in the front end you have a normalized cache of feed item things. Awesome. And let's say someone clicks like, so now that means we need to refetch the feed item to show the new like or something, right?
Yeah.
And if you have a GraphQL API that has an entry point, or a REST API that gives you like /feed, or like the feed field that returns a feed, you have a problem because you cannot refetch that one item in the feed. You can just fetch the feed, and so overfetching. Spicy take. So
it is spicy.
Yeah. Where was I? Relay, refetch. Okay. So in Relay, there's a pretty cool concept. It's this node interface, and the node interface, it means that you can send a node ID, so like a unique identifier of a thing. You can send it to the server, and the server will refetch the thing. And so instead of fetching the whole feed, you can refetch the feed item just by giving the server an ID.
Okay.
Yeah, that's pretty, like, it's a great concept, and it would be nice if you can just support it in Federation. But there's a problem, because you have entities. There's a problem and an opportunity. So you have entities, and you have this node ID. And so if you have a node ID, the problem is you take the node ID and you figure out what kind of entity is it, because it can be many things, like all entities. So it can be whatever. So you figure out, okay, it's a feed item. And once you know it's a feed item, you need to know in which subgraph this entity lives. So just by sending a node ID to the router doesn't yet know where to get it, because the router, like, how should it know? Like, if it was an entity, then we know, okay, it's an entity. We know what is the key, so we can jump to a subgraph and get the entity by the key. So what we need to build is like a mechanism into the router that understands how to turn a node ID into an entity. And then once the router has an entity, it can fetch from the right subgraphs the stuff. So somehow, you know, I don't know, I somehow call it like in each entity, it somehow has like a home. Like it has one subgraph that is the home of an entity. That's like the entry point.
Yeah.
And so what I'm currently thinking, maybe that's naive, maybe the people on the stream have a better idea, and you can comment that. But what I'm currently thinking is that we somehow take the GraphQL schema, we annotate it, and say this entity should be a node. It should have implement the node interface. We just annotate it somehow. And then what is happening is, okay. So what we will do is we annotate the entity, and each entity, it has this key directive with fields.
Yeah.
So my idea is that we create a field. It's called node on this entity, and that's the node ID. And the ID, it will actually be a JSON Web Token, so a JWT.
Okay.
And in the JSON Web Token, we put multiple things. So first of all, we put all the keys of the entity. So if the entity, let's say the entity has ID and SKU, we put into the JWT ID and SKU. And then we put into the subgraph where this is coming from, and we sign it. Because if we sign it, it means, or imagine we wouldn't sign it. So a client comes to the router and sends us a node request. One thing is missing. We need to have a type name. So we need to have the type name. So feed item, the keys, and the subgraph where it's coming from. Actually, I'm not even sure if we need the subgraph. I think type name and keys should be enough, and then the router can figure it out. Okay, so we have this. We sign the JWT, and now the client sends us the request with the JWT. Why a JWT? Imagine the client sends the request, and it gives us type name and keys. We would assume this combination of type name and keys exists, or at least we need to validate that it exists.
Yeah.
So the router kind of needs to trust the client that this combination of type name and keys, that we actually have it. Or so it can kind of be an attack, because keys are kind of like an internal concept, and you don't want clients to guess. And so if you don't have this JWT, clients can just send whatever combination of entity keys, and then they can figure out, like, if the server always says no, it doesn't exist, no, and then eventually they say, oh yes, this exists, then it means the client can guess entities. And I don't think we want clients to guess entities. So we give the client a JWT, we sign it. So the first thing that happens if we make such a relay node signed relay request, we verify the JWT. So we know, okay, we, the router, like ourselves, we created this JWT because we can validate the signature. So that means, first of all, we can trust that we should process this request. That's good. It's not authentication at this point. It's a JWT, but we're not doing authentication. That's like authentication already happened. Okay. So we now know that we can trust this combo of type name and keys. And so we have translated the no relay node request into an entity. type
Yeah.
name and keys, and we know what fields the user wants to have, and now we can make our entity calls and fetch it. And so yeah, then Cosmo Router could natively support Relay. I think that would be super dope. If anybody likes this idea, then I don't know, give it a thumbs up or react or whatever. Comment, like, and subscribe.
You're getting into your streamer set. No, it makes sense. And I mean, there's a lot to unpack there, but
Okay, now you explain. Like, have you actually listened? Explain to me.
no, I'm not explaining Relay to you.
I'm
The thing
kidding,
that
I'm
most
kidding.
people say about Relay is that the fact that you have to use Relay, it is one of the best clients to use though on the front end if you're working with GraphQL. But no, what was that tweet that went viral of yours that you can't have a discussion about Federation if you're not if
About
Relay is
GraphQL.
not? Yeah. You can't talk about GraphQL if you don't mention Relay, right?
Yeah, but
Yeah.
honestly, I think a lot of people who like GraphQL, they are not like I like, or a lot of people who really like to use GraphQL, I think they are not just like, hey, I really like to use GraphQL, but it's more like I really love Relay, and because of that, I'm using GraphQL.
But what makes Relay so special? Like abstract the way the GraphQL, like, okay, like there's a bunch of front end clients out there, React, Next.js, and then there's Relay. What makes Relay so special? What makes it so good? And why aren't more
Okay.
people using it? Also, Relay is open source from Facebook, right?
Yeah.
Okay.
It's just the way it works. So, let's say you have a UI component that shows you the feed with not so much detail. So you create a fragment that defines what fields you need to have this overview. Okay?
Okay.
All right. So you have the fragment for this component. Then you have, like, let's say you have a feed detail page. So in the field detail page, you also define how you query the thing and everything, and you have a fragment for that, and you define the fields you need in the detail page. And let's say in the detail page you need more fields than in the overview because it's more detailed. Okay, good. So state one, we deploy it, and then product owner says, detail page, I don't like it, please make changes, please remove something. So you remove a field from the fragment of the detail page, and by removing it, you then run the relay compiler again. And what the relay compiler does is it figures out that on each path of the page, you combine all the fragments, you hoist up from the child components to the parents, you hoist up the data requirements, and you build a unified query for this page to load the page efficiently. But
you
here's
can
the
see
problem.
By the way, when you said that, you can kind of see the similarities of why GraphQL pairs so well with Relay.
Yeah, exactly. That's why you need fragments and selection sets and these things. But now here's the thing. So let's say you have TRPC. So you create a TRPC call that gives you the feed data. And because you also need the detail page, it loads the feed and also the detail page data. So now in your front-end component, you remove this one thing because the product owner said we don't like it.
Yeah.
And so in TRPC, you would not remove a field from the fragment. But with the right tooling, if you have a field in the fragment and you're not using it, you get lint errors. So it's like, hey, why are you fetching something? You don't need it.
Yeah.
Okay, fragments, relay compiler, it figures this out. So it tells you, hello, remove the field. Then we compile it, we hoist up our data dependencies. And now the field is actually gone from the page query. If you do the same thing with something like TRPC, and not against TRPC, I think we use it, or maybe we don't, but it's a good thing. So don't worry, good thing.
The good thing.
But yeah, but the point is, let's say you are like a big company like Meta or what, Coinbase or whatever, and you have teams of people, and everybody changes UI components over time. It means that data dependencies for UI components, they change all the time, and nobody knows like a complete map of like a complete tree of everything. So you are deep down in the tree, you change that one component, you remove a field or you add something, and now you need to go through 5 layers of UI components to manually figure out, do we really need this field or don't we? So, and let's say you have a REST API. So what happens is you make a REST API call in the root of the component tree. You load the data for this tree. Someone in the child tree, in the children of this component tree, they say, we need another field. So you go all the way to the root, to the REST API, someone adds it there. Okay, nice, it's now working. You deploy it. Half a year later, you realize we changed the feature. You remove this field. Do you think anybody is going to remove it from the REST API? No, it would be a breaking change. Like removing a field from a fragment, it's not a breaking change if nobody's using it, but you need to know who's using the fields. So you need to hoist up all the fragments and see, are we using it? Are we not using it? And if you don't have Relay, you cannot do this. And Relay can only work with a query language that allows you to have selections on the tree. So yeah, you need GraphQL to do that. And if you have ever tried to build UI at scale across teams, like not like, oh, we have 2 front-end developers like WonderGraph, like we don't need Relay, but if you build front-end with like 100 people, you have different set of problems. And this is where Relay shines. Where this approach Relay shines.
No, it makes sense. It also makes sense in the name too. I actually never thought about it that way. And then when you explain it, I could see why it makes so much sense with GraphQL. And it makes sense when you would use Relay. If you have multiple teams that are creating multiple components, multiple changes, you're a big scale company, things change. It absolutely makes sense. It's interesting. But okay, so going back, so we went on a tangent as always. We went from APIs, we went with the future of Federation. Federation is held back by GraphQL. I can't get that out of my head. Like, what is the next iteration for Federation? Where do you see this world going? And I asked this question again, but why aren't more companies adopting Federation? Sure, you have the Gardner metric. People are like, yeah, we're adopting it. But this whole point with Relay is, why aren't more companies at scale using Relay? Why aren't more companies using Federation if it clearly makes sense?
I think this is, it's kind of easy to answer. Like, how many companies are there where you have 100 front-end developers or more working on a website?
I mean, thousands. There are hundreds of thousands probably. There's a lot.
No.
You don't think so?
Like that? No. Like, you know, which company has 100 front-end developers? Like, I'm not saying developers, but what company has 100 front-end developers working on front-end, on one front-end?
Yeah. Okay.
Like, yeah, sense. Meta and Coinbase and some others, but ultimately the surface area of people, like, I don't know, you know, and it's about practicality.
But wait, because this is the biggest argument that I see a lot on Twitter, is that people adopt Federation, or they adopt GraphQL, or they adopt Relay, and they have 1 or 2 engineers. And so what they say is, we tried GraphQL, we hated it. And then you ask them, okay, why'd you try GraphQL? Underfetching, overfetching problem. Okay. And also, we only had a couple developers. Do you think Federation and GraphQL will ever make sense for these companies that don't have 100 front-end developers?
Yeah, I think we need to change some stuff.
And what would we change and why?
If you so I think the first question to ask is, does federation make sense without GraphQL? So in other words, does federation make sense without relay?
Oof.
And we just talked about it. I think again, relay is awesome, but it also comes as a cost. Like relay is not super easy to understand. For a lot of people, I think RPC is easier to understand. Like MCP doesn't want GraphQL; it wants RPC.
Yeah.
JSON RPC to be more specific. So how can it make sense? And is or in other words, does federation make sense without relay? And I think the value of federation is we build an API with many teams, or we create a uniform API interface across many teams. And I think that's a lot of value because being able to have a uniform schema with entities, being able to have clarity what our entities are, so clarity in the domain model and everything, clarity in the descriptions. I think it has a lot of value. But there's, I think, a much bigger use case, and that is,
okay.
You know, all the people who build SDKs,
Yes.
who build REST APIs for others to integrate these APIs into the system. Can we create a uniform approach where we make it super simple to create SDKs from your supergraph? Because with that approach, we could open up federation to not just relay users, but to you know, one thing I kind of realized about the open API community is that a lot of people they use open API to describe REST APIs, but what API consumers actually want is SDKs. So what we're thinking about is, you know, similar to MCP. If you want an SDK, if you want MCP, what really is the difference? Because for me, an SDK is generated code that where each the functions or classes or structs, whatever, and I can somehow call a function and it does one thing and then it returns some data. So what could we do to turn a supergraph into an SDK? We create a collection of GraphQL operations like MCP. And then because we can describe each operation, we can group them in folders or whatever under names.
Mm-hmm.
And then each operation, it has an input, JSON schema. It has a response, JSON schema, and then we generate an SDK. And so now I think we take the concept of federation and we open it up to like a whole new surface area, and that will give so many people like something like a uniform platform for like, okay, here's our SDK, this is how we can use it, and now you kind of make accessible your supergraph to anybody without understanding GraphQL, because what this SDK does is it calls persisted GraphQL operations, one function at a time, and now anybody can use the graph, and that is one part where I think or where we are currently going, because
well said, by the way. You went full picture from the very beginning of the podcast all the way to the very end, including relay. It makes sense, but continue. What was the second part you said?
No, you just stopped me.
Oh, okay. Sorry, I just wanted to call that out. The way that we did a full picture, I really like that. I mean, it makes sense too, and this is how you go beyond GraphQL. But one of the biggest things I talk with like other startup founders, friends, is that the dev tool space. So technically, we're in the enterprise tooling space. We sell to enterprises, but in the dev tool space, the only way to make a successful dev tool is if individual developers can use it, and then you have a clear ladder to a group of developers can use it, and then an organization of developers can use it. That's the only way a dev tool can be successful with the collaboration. Where do you
Where's this
see?
definition coming from?
That's just my own like razor that I have. Is that that's how dev tools are successful? Is that an individual developer can use it, a group of developers can use it, and an organization of developers can use it. If you can't hit those three, and a lot of companies fall short, is in they have a good tool. We did. Individual developers used it, but we didn't have teams using it. And this was the WonderGraph SDK. We tried it. It didn't really work out that well. But with Cosmo, what we're seeing is we're kind of going backwards. We're seeing the organizations of developers can use Cosmo and that they love it. And it's what you said. You're expanding beyond Federation. You're expanding beyond GraphQL, and I like that. But where do you see Cosmo going in collaboration that organizations, teams, and eventually the individual developer can use it? Do you think individual developers will be able to use it when they're building their projects and things like that to open up what you said, their graph or their app to other developers to integrate easily with it? Also, do you like my definition of what I think of dev tooling? Or do you disagree with it?
I think DevTools is really hard. You build something. Let's take the example of Prisma. I really like Prisma. I would have really hoped for them to be successful. Maybe they are successful. To me, they don't look successful. Maybe they are. But so you build an ORM in the hopes that you build a massive group of people around you and you can somehow monetize it.
Yep.
And then comes Drizzle and all your dreams fall apart. Okay. bad joke, but
It was a good show. It's true though, sadly, yeah.
no, okay, for real. So you build an open source ORM. How do you monetize an ORM? Because what you kind of need, like, it's I would say it is our definition, but if a commercial, I like to distinguish open source and commercial open source. If someone builds a Drizzle open source to help themselves use Drizzle, and they are not building this as a startup, but more as a means to an end, it can be a successful thing.
Yeah.
If you build Prisma with the intention to make money, I think what you need is collaboration.
Yes.
And by collaboration, what I mean is there's two ways. You could sell compute or you could sell collaboration. And I think most startups fail in selling compute because you essentially you are wrapping a service. You are wrapping AWS. I would say Vercel is not an AWS wrapper because what they have created in terms of complexity of the platform, it goes far beyond wrapping. The whole experience from protection against threats to CDN to it's not a wrapper. But if you are Prisma and you have I don't know what they announced something. I think some component for subscriptions or whatever.
It's like
real-time.
Boost or something. Yeah.
Yeah, something. Okay. So they take this one thing and they put it on compute somewhere and they sell it as a service. You have the WonderGraph SDK problem again. So what we pivoted away is because developers have a natural tendency to not buy services for singular problems.
Correct.
Actually, developers have a tendency to not buy anything.
Yes, that was clip that. Yes, it's very true. Individual developers. Yes, I agree.
Like they what developers do is they go to their boss and say, "Hey, can I have an AWS account?" And they get an AWS account, and then they buy whatever they want. So that is the thing, and they buy like a database, whatever, and they EC2, and they call it a day. But if you have your Boost thing or whatever, you put it on compute. What happens is you buy compute for $1 and you sell it for 3 or maybe 5 or 10. And people will at some point, maybe they use it, maybe they don't trust you even, so it fails at that stage. But even if it doesn't immediately fail, then people will be like, okay, but it's so expensive, you're just a wrapper, like why am I paying $10 if it could cost 1? Can I not self-host this thing? And then you're like, yeah, but self-hosting is more complex. And they will be like, yeah, I don't care, like my time is worthless, I don't value my time, I can do everything. And yeah, so I don't know, it's not a world I want to be in. So like, yes, you can somehow resell compute. To be honest, like so many startups are just compute resellers. Like you are just an AWS reseller with, I don't know, some fancy whatever, but I don't, yeah.
And you
Forget
can make
about
good
it.
money doing it. You can make good money just being a reseller. You can improve the experience a little bit. There's startups that their whole premise is AWS without the AWS, but you eventually
Yeah,
hit
but
that point.
there's this one company. What was the name again?
Which one?
They resell AWS actually.
Is it?
You know what I mean?
I'm trying to think of the name. They resell like the credits. Is it flight
No,
control?
no. They give you a new experience on top.
Is it SST?
No, that's
Flight
not the company.
control. Dex. There's flight control. There's SST. There's fly.
Yeah, similar.
Okay. I'm really trying to remember. Is it Pump? Is it?
Nope.
I don't remember. But okay, just say it's just a company that just basically sells you AWS with a better.
Yeah.
It's
Yes.
Railway. Is it Railway?
Yes.
Okay,
Yes.
Railway. Yes.
Yes. You know, in my 700 years of being a developer, I have really learned one very important thing. You buy databases and compute from AWS, GCP, or maybe Azure. And you just don't use startups because startups absolutely suck at reliability. And if you think it cannot get any worse, then try Fly. Like,
Yeah, it was bad.
We tried. Bad, like we wasted so much time trying Fly. Like just don't use startups for compute. It's it's really hard to do compute. It's so hard. Okay.
Wait, real
And here's
quick,
the thing.
real quick note on that one. These startups move slow, or not startups, these companies, AWS, Azure, GCP, but there's a reason that they move so slow. When you're that big and you have that much reliability, it would be ridiculous to choose anything else other than the go-to one, which is Azure, GCP, and Azure. I like how you said maybe Azure. That was kind of funny.
You know what's crazy? So we have a Node.js component in Cosmo in our cloud. It's called control plane. Node.js. Like it's not like Node.js is not, it doesn't stand for stability or anything, or like best tech or whatever. It's just, yeah, okay, Node.js, whatever. And we have this thing now running for a couple of years. Like, of course, we update it, and it's running on Kubernetes, on GCP. Do you know the number of incidents?
A big fat zero.
Yes.
Zero incidents. Yeah, I know.
Like it's insanely boring to use Kubernetes on GCP. insanely. Like we even paid extra money for like Dustin, our CTO. He figured out there's like a thing, and it automates the cluster. So we're not managing a cluster, and because like who cares?
Why? Yeah.
And so it automatically does stuff, and we never had an outage, an incident, nothing. It's I don't know. Like I'm not like advocating for GCP or sorts, but I can just say this stuff just works. It's crazy. If you want to build a startup and you don't want to waste your time on infra, whatever, just use GCP. I'm pretty sure AWS is the same game, but this stuff just works. If you deploy something on fly, then suddenly on a Friday afternoon, your deployment is gone, and you call a number or something because you have an SLA, and nobody answers. And if you're lucky in some forum on Monday, you get an answer, and then you just know, okay, like let's run. I don't know how they managed to raise so much money, but yeah, okay.
Yeah,
So
spicy. Well said.
Yeah, so this is the category of we buy compute and we resell it more expensive. And to be honest, I think it's a it's a numbers game, but if given enough time, so given infinite time, the margin for your reselling will go to zero.
Yeah.
So I don't know. Your business model is designed to fail. I don't like it. But what I like is collaboration. If you enable 100 people to build an API together, and they build a workflow that really works for them, that's powerful, then imagine Linear.
Yeah.
So we are using Linear. Our team is growing. Every time we add a new member, we onboard them to Linear. So what is happening with the value of Linear for us?
It's going up.
It's going up. And so that means over time, collaborative tools, as you add more people, become more valuable. You put in your tickets, you put in your documentation,
everything.
And so Federation, building APIs across teams, collaboration. So on the one hand side, you have infra, and you have like schema registry, and we do this for our customers. And on the other side of the spectrum, you have collaboration, and where people work together, build subgraphs and everything. We will talk more about this topic in the future. We first need to figure out some things, but we're the kitchen is busy, I would say. Yes, but on the other hand, you can kind of see, like, I'm not just ranting, but it also
Really?
guides our own decisions, because Apollo built a service to host routers for customers. This is ridiculous. Like,
Why?
I don't know. Have they killed it already, or is it still alive?
It's still a thing. I was talking to somebody the other day about it, like a hosted router solution and wrapper on top of wrapper.
So like, given our experience with the SDK and our learnings from, like, how hard it is to run compute at scale, like, why on earth, like, I know they have more than 100 developers, but why on earth do you want to run routers for people? Because what it means is you have to have people on call. Like, you have to make sure everything works. If a router doesn't work, it can be your fault, it can be the customer's fault. I don't know. And then at the end of the day, how are you charging? So you can find some sort of proxy metric. For example, you can invent, I don't know, TPS or whatever, or
something like egress, something
graph
weird, like
compute unit, whatever.
Yeah.
And this is all bullshit, because what you're doing is you take the compute from AWS and you put something on top, and now I can so you put your margin on top, and now I can draw a line. If I put, I can draw a graph, and if I put big enough numbers into this graph, I can now calculate if I use the managed service versus I build a team to run routers, and then you can see the graphs of the cost, and you can see exactly at which point you should stop using such a service. And here's the problem, because in most cases it never makes sense, because if you have subgraphs, it means you have a platform team that operates the infrastructure to run subgraphs. So it means the company that uses Federation, they already have people on call that the subgraphs don't break. Because if they break, you're offline. So let's say you are, I don't know, big company, Coinbase. If your subgraphs are down, nothing works. So if you now use a managed router, what happens is, if the supergraph doesn't work in production, two companies now need to collaborate to fix the problem. So you don't just buy a managed router, you also need people on call internally in case of an incident to figure out, why is it broken? Is it us? Is it them?
Yeah.
And you're paying extra for, like,
it doesn't make sense.
What?
It doesn't make sense. No, I'll leave you it there. But one sec, my dog is like freaking out. But if you guys haven't seen,
Sorry for the rant.
This is Cosmo's mascot, so this is Cheeky. But Cheeky, get out of here. Not gonna lie, I think this is a fantastic episode. We touched upon a lot. Next week we're back, which will be really exciting. We're gonna start bringing more guests onto the show. It's gonna be more technical focus. We're gonna bring experts that have experience running Federation at scale or just working at hyperscaler companies. I have no closing notes, but Jens, what's the good thing?
The good thing is we are back next week.
Awesome. Great episode. Thanks everyone for tuning in. Be a little bit more collaborative, though. Post some questions. Do you agree with Jens? Do you think that he's crazy? Do you think he's off his rocker? Do you think collaboration is stupid and compute is where it's at?
Stefan,
feel free to post your comments into there. Go ahead.
If you don't raise your hand, you agree.
Yeah.
So everybody agrees.
That's fair.
I think we're all in agreement.
Quiet mouths don't get fed. Thanks, guys. See you guys next week.